Okay. So, I'd basically been sitting around trying to optimize Doom a little, and Quake as well, but not having quite as good of success at making that usable. But and also a lot of debugging recently. Yeah, fix the low detail mode as well, which improves the frame rates further. Yeah. So, well, guess it's not too noticeable with this webcam, but frame rates are generally solidly into the double digits now. Generally on in my testing, I'm typically getting between about 16 and 20 frames per second, so that's a bit of an improvement over what it was. This is still at 50 megahertz, so at least means that Doom frame rates are on par with early 90s hardware. So that is at least a bit of an improvement. Curious. What was, I think, different from before? Might have been debugging or something, but yeah, I think in the past that pathway didn't go down, and now it does. Curious. Yeah, I do know I was debugging a bunch of stuff recently, but I hadn't expected that. But granted, I've not actually played these maps much, like outside of my emulator tests, and I'd actually got the Ultimate Doom WAD itself partly, well, for this testing. Previously, I was just, if I was messing with Doom, I was just using the shareware WAD, but figured I'd add, some more variety, since I'm messing around with it a lot more with this testing. And I'll see if it is more stable now. It should be, because I did, fix some of the bugs. Curiously enough, most of the bugs I've been finding haven't actually been either in the CPU core or in my compiler, but rather have generally actually been bugs in my C code. A lot of it for things like the fat driver, and also some bugs in the C library and other stuff like that. So yeah, the previous crashing and other stuff like that. a lot of that was actually apparently mostly due to bugs in my FAT driver and C runtime. So, yeah. But some elusive bugs remain, so the possibility of it crashing can't be entirely ruled out. And of course, this next map is one of the ones where crashing tended to occur most often. Particularly, I go through a little ritual of basically, well, not killing anything in the prior map. So, yeah, on E3M2, seems the rule is don't kill anything, and then usually it's kill or get these two guys angry. Seems to be part of the process, and then I would run over to this part of the map near the exit and kill these guys. And then usually the process would be run around a little. In the past when stuff was still being really buggy, this pattern tended to fairly or semi-reliably generate a crash on this map that I will see. Usually at this point, exactly when it crashes would be itself pretty random, but it seemed to be that that particular pattern was a good way to set up the crash. Of course, if you did stuff differently than that, and sometimes if it just felt like it, everything would proceed on like it theoretically should, which is, no crashing. But yeah, so never did figure out a way to get it reproducible with 100% certainty, but usually if it's was going to, it would have done it already. But after fixing some of the fat bugs, I've not really been seeing that particular crash happen so much anymore. So could have been I fixed it. Maybe. Or the next variant. It happens once one exits a level. So wait here for it to cycle through without interacting. Well, apart from this part, hit something to make it go, but after a few seconds, it'll either go to the next map or it will crash. And it has gone to the next map. Some frame rate drop here. Yeah, it seems to be noticeable on the video, so yeah. other than optimizing and debugging, had recently been yeah well, I'd been working on adding some dithering support. So the basically so the dithering is well, in contrast to the options of either just sending straight unmodulated um, output, still like the VGA pins, which is one option, but it sort of looked pretty bad with only 4 bits of 4-bit DACs on this thing, so that was not great. And the other option was trying to PWM the pins, which caused some pretty noticeable artifacts at this monitor. But I've determined that this monitor isn't actually or is actually fairly old, so yeah. For contrast or for explanation, I did recently look at the back of the monitor and saw that it had a date of manufacture on it, but this monitor was made in 2002, so it's kind of not exactly a new one. Yeah. Well, either way, this monitor, it's kind of fuzzy about what inputs it likes. So little things little things will make the monitor unhappy. So types of things this monitor didn't like. Well, one thing was PWMing the pins. Another thing of which it didn't like is especially didn't like if you PWM'd it during like the blanking intervals and or the horizontal and vertical blanking intervals. That caused all sorts of artifacts, sort of guess kind of like macrovision or something, I'm guessing. Just sort of like massive like strobing on massive strobing on the screen, and light and dark bands and all this other crap going on. So basically seems that for the front and back porches during the blanking intervals, it's all like have to set that at a constant value and leave it there. So no changing the intensity at that point. Similar during the vertical blanking interval. Needed to also not PWM anything at that point. Otherwise, monitor, it wasn't happy. And it also doesn't really reliably detect that I'm outputting 640 by 480 either. Sometimes it'll just randomly think it's like trying to pick up 720 by 400 and make things look kind of weird, but that's kind of annoying. Not figured that one out, but I think that one's timing. But what I was getting to was, so yeah, rather than the previous options of either do nothing or PWMing the pins, neither of which were getting particularly good results, I've discovered the idea of essentially using a Bayer dither, or yeah, order dithering type stuff. See, so can you see this? Oh yeah, I'm just looking at the Wikipedia article on dithering here, but hmm. I'm not sure if there's anything. No. Yeah, this one, more or less. Oh yeah. But in any case, yeah, Bayer dithering. Um, I did mess around with basically trying various techniques for, well, XORing a frame number with the index into the little Bayer matrix thingy, um, to try to minimize noise and stuff. Oddly enough, it seems that the first guess I had, which is, just a straightforward XOR, was actually apparently the best option. The dithering is still slightly noticeable, but a lot less than in some of the other variations I tried. So, and also a lot better than, well, not doing anything and just, just using a straight up dither. That had actually the most noticeable artifacts were most noticeable artifacts. So, hmm. So yeah, if you sit across a room, the dithering effect isn't too noticeable, but if one gets and looks at the monitor closely, it is a little more noticeable, but yeah, still an improvement over what I had before, so not all bad. Also, I determined that, this monitor also had some ghostly banding artifacts which occurred, but I determined that the way to fix that apparently is to more or less align the dither pattern with the pixel edges so that they both change over at the same time. It seems if they're not really aligned that closely, then there's still some pretty obvious banding similar to what happens with the PWM. So it's possible that it's a related effect. As for why this monitor cares, I'm not that sure, but yeah, fun crap there. For low detail versus high detail, it's noted it's in low detail right now. Switch it to high detail. It looks slightly better, but frame rates are worse. So low detail is generally preferable on this. Yeah, yeah, for making low detail work, I did actually have to put in a little bit of effort there because it seems that, well, yeah, it seems that, like, yeah, in the Linux Doom source, like, they didn't really bother maintaining that, so it kind of fell into disrepair a bit. And, yeah, so if you try turning on low detail mode, well, stuff was pretty broken, like the floors weren't aligned with the walls or really anything, and yeah, kind of had to figure out the various things that, or yeah, had to figure out the various things that were acting up and proceed to fix them. Yeah. Yeah, so notable things. Yeah, so had to fix everything that was broken in low detail mode to make that work, and that sort of helped performance. Also, what helped with performance some was, rewriting some parts of the rendering in assembler. Yeah, the logic I used was kind of similar-ish to what the original x86 version was using, but noted some that, well, optimization on my instruction set isn't really that much like optimization on x86. For example, x86, it seems, if you want to use less math, you can, or if you, in general, you want to use less math when possible, and one way to do that is via lookup table. But on lookup tables, those are not helpful on BJX2. Like, using a lookup table can actually make the performance worse. So, oh yeah. So not really so much of the whole, not so much of the whole free lunch thing there. It was actually getting more of a performance gain by taking some stuff that was using lookup tables on the x86 port and actually switching it to using direct calculations. So sound volume mixing, no lookup tables. Now it's using subtraction and multiplication because multiply was faster. Yeah, each multiply on here is about 4 clock cycles, and the cost of doing a lookup table, it's pretty variable, but it's, if it doesn't fit in the cache, then it's, well, a lot more than 4 cycles. So yeah. Not been around this map as much, so offhand I don't remember where the exit's at. But there's an exit around here somewhere. Okay, here's the exit. Of course, this map means time to shoot the spider mind. Long range cacodemon there. Or I think. Pretty sure the blue and red one is the cacodemon. Don't remember that for certain either, but it's either either the blue and red one that shoots balls, or the one that, or the brown one that shoots lost souls, but one of those two. So yeah, spider mine dead. And, well, pointing out that Doom is to a reasonable extent can be considered working. Apart from audio quality and MIDI playback on the FPGA, which still doesn't work annoyingly. That's probably more debugging, but haven't got around to it yet. Epic Doom finale cutscene. This is something which was kind of lacking from Doom 2. It's all like Doom 1 has this, little exit cutscene of sorts. And Doom 2 doesn't bother. It's just like, yep, we kill the final end thing and get a text scroll. That's, not quite as exciting. Could have gone a lot more elaborate with this, but still, oddly enough, I've not actually looked at the code enough to really figure out how this cutscene works. Like if they're using something similar to the sky effect, or if they're doing something different. But yeah, something or another. Of course, I can still exit back to the shell, so that works. But if I try to launch up Quake, it's probably going to crash. But I will see. I think I saw a brief flash of the prior contents of video RAM there, but yeah. So, doesn't appear to have crashed yet. So Quake frame rates are still pretty much crap, but sort of a little bit faster, I guess. And there's some graphical glitches due to bugs, and some others due to some potentially misguided optimization attempts, but was trying lots of random crap to see if I could improve the frame rates on this. So lots of random things like lots of random things like trying to delay how often it does the redrawing surfaces in the surface cache thing, but it can result in some artifacts when moving, especially noticeable at lower frame rates. So yeah, surface cache bugs, and then some others related to texture coordinates. I'd tried some things like basically not or partially compromising the perspective correct texturing and for short spans to reduce the amount of math required, which helped a little bit, but not enough to actually make the frame rates usable. As can be noted, may or may not be like all that relevant, but I guess yeah, unlike the original x86 DOS versions of Doom and Quake, this version is not actually using index color, so or not actually using 250 or 8-bit index color like the original DOS versions, but it's actually using essentially packed YUV for all the pixels. So in that sense, they're kind of almost halfway turned into something like Half-Life, but the difference is Half-Life was using packed RGB pixels, whereas I'm using packed YUV pixels. So I forgot if there's any options to make stuff faster. And always the good old option of cracker boxing it, which makes it slightly less awful. So yeah. Using packed YUV for the pixels and to some extent replace. Oh yeah, may or may not be noticeable, but yeah. Besides the packed YUV, also the console is translucent. Yeah. One might think that a translucent console is a gratuitous waste of processing resources, but actually from the way this optimizing on this instruction set works, it's actually not too gratuitous. Because things that are expensive are mostly, well, memory access and also things like lookup tables. But things like arithmetic are actually a lot cheaper, so you can barely afford the general rendering task as it is. But what you can afford, strangely enough, is random little niche features like, translucent console. And also the menu, the background there is also translucent. So yeah, I can afford the math for doing alpha blending. Just not really for more useful things like, actually clearing the screen memory. Or at least that was for Doom. I tried adding screen memory clearing sort of like Quake, but Quake, I think, might still do it. Luckily there's an easy way to test it. Yeah, I still clear the screen. If I didn't, as soon as I go out of the map, it would basically be a Hall mirrors effect, so. But that does point out something I can try as a possible optimization. Because when I tried adding the screen clearing to Doom so that it would and when I added the screen clearing to Doom so that it would not have the Hall mirror effects and no clip out of the map, it did have a pretty noticeable effect on the frame rate. So it's possible I could try disabling it on Quake and see if that helps any. As can be noted, Quake doesn't look nearly this glitchy when I'm running it in my emulator, but for some reason, yeah, there's a lot of bugs that manifest on the FPGA core version, and I've not quite figured out why yet. And of course there's also simulation, or the Verilog simulation, but that's well, way too slow for Quake to be considered interactive. Oh yeah. Should be a Verilog simulation running. And yes, it is. But as an evidence of this being slow, it's spinning for this particular instance. It's been running for some odd number of hours, and it's, well, still not gotten Doom all the way started. Getting from first starting it up to it actually being to playing the Doom demo and stuff in the simulation typically takes about one or a day or 2 days. So yeah. Something in that area. In any case, it's does take generally about a good solid day or so for it to get through, this crap. So if I were to leave it running as it is, probably by sometime tomorrow, I might be seeing like, you know, the title screen or something. But yeah, as is noted, the little blinky dot, that's the raster refresh. So every time it goes from the top of the screen to the bottom of the screen, that's about, well, theoretically 1/60th of a second. So ding, another 60th of a second. I have to count exactly how long it is, but I do remember that it is, yeah, somewhere in the area, basically, over 1,000 times slower than real time. So yeah, each time it moves from one of these numbers to the next, that's 1 millisecond. Yeah, about 1 millisecond every second. So about 1,000 times slower than real time. If there's one thing that's not particularly interactive at 1,000 times slower than real time, it's Doom and Quake. Because, you know, I'm not going to be standing there holding the keys for as long as that's going to take. I actually did try once before to operate the menus in the Verilog simulation, but seriously, I'm not going to hold down the keys for that long. Yeah, one other thing that you can note here is notice how some of the enemies are not being, or yeah, some of the 3D models are not being particularly, like, you know, correctly dark or correctly lit, but that's because I did end up like compromising the light blending math for the alias models to try to make them a little faster as well. Basically, for being more properly lit, it's necessary to scale the UV components along with the Y. So basically, as it gets darker, the UV or U and V values move closer to the neutral value, or 128 in, like, you know, traditional sense, but the math for doing that is kind of annoying. So and I've just made them mad. But yeah, the math for you know, the math for, like, you know, scaling the UV values is, you know, well, not exactly free. So So yeah, compromised it. I guess, it's notable that I'm using direct calculation for lighting these alias models as opposed to using the color map. But as noted, um, by that point in the rendering, there's actually no access to the original index colors to begin with, so not really a whole lot of option there. In order to have stuck with the color map blending, I would have had to basically kept the skin textures in the form of 8-bit index color, but in this case it's, yeah, the texturing and all that stuff is all happening as YUV. So maybe or maybe not ideal for a severely underpowered core, but yeah, probably not the best option for the memory bandwidth either, because that's the main bottleneck on this thing. And if there's one thing that doesn't help with like limited memory bandwidth is bigger pixels. But could be worse. Could have been using like 32-bit pixels, in which case, yeah, that's well, even worse. But yeah, because I'm using the cheapest I could get away with, which is basically 16-bit pixels. As for YUV versus RGB, well, there's pros and cons there. And, okay. My webcam is not happy. I unplugged it, so that maybe. Message seems to have stopped, so yeah. These webcams, well, they were cheap, and oh yeah, no more webcam feed. So yeah, these webcams were cheap, but they seem to actually pull a bit of power and are a little bit prone to overheating. Because scarily enough, that webcam, the cheap webcam I was using, pulls like a good solid 500 milliamps or so, which is kind of extreme for like a webcam. But meh. And then I had to grab another one of the cheap webcams I had because the first one I was using stopped working. Like, so some combination of uses a lot of power and then decides it doesn't want to work anymore. possible means I should get like, some different webcam that's actually not crap, but something like that. Yeah. But yeah, back to the topic of, yeah, why UV versus RGB. Yeah, there are trade-offs there. Um, yeah. So, for example, yeah, why UV? Well, crap, losing my train of thought. But yeah. Yeah, I'd originally used it partly because it made the color cell encoding a little bit easier because it allowed the trick of basically treating the pixel as a single value and just interpolating it directly in crap and just being all like, meh, good enough. Pick the lightest value and the darkest value and assume that everything else is between those. So pretend it's 16-bit grayscale. So if you pack Y into the high bits and then you pack it basically in a YVU ordering. So yeah, basically your luma is your high value bits, and then followed by your red component, and then followed by the blue component because who cares? Blue is the least important. Could treat it like grayscale and just do color cell encoding directly off of that, and scarily enough that worked. But if I'm not using grayscale, or if you're not using color cell, then arguably YUV pixels make less sense. And for things like blending calculations and lighting calculations, those actually work a little bit better with RGB. So yeah. So yeah, lighting on RGB is you multiply everything by or multiply all three components by your scale factor and call it done. Whereas lighting on YUV involves a little more math than that. Initially I thought it would be cheaper, like you could just add or subtract a constant from Y and then pretend UV are the same, but then I determined no, that's not really the case. So you have to add or subtract something from Y and then scale U and V, or you can scale Y, U, and V, but then you also have to add and subtract biases as well to make sure their center point stays the same. So yeah, so it's more math overall to scale YUV pixels. Which, as noted, possibly not ideal for an arguably underpowered processor core. And not good for Quake frame rates, so yeah. And of course, my Quake image isn't going to be changing there because, well, my webcam has crapped out again for now, so case, yeah. What was I thinking? Oh. Lost my train of thought here. So, yeah. Bayer mask. It feeds the low order bits of the pixel into a case statement that gives you the bit mask for how many of those bits should be high, and just sort of grabs the bit for the Bayer index, and that's your whether it should round up value. So nothing too notable. Yeah, actually remembering some other optimizations I did. Um, seems an area in Doom that like no one had bothered optimizing, but which was actually showing up in the profile here was like how quickly it could look up lumps in the WAD file index, or yeah, lump index, or whatever you want to call it. But originally it was just using a linear search, so it would linear search through all the lumps whenever it would need to fetch one. And I don't remember, I think it might have been using strnicmp as well, which is also not ideal. But I changed it mostly to using hash chains, so it'll first off make sure everything is uppercase beforehand, and it will calculate a hash index, a hash chain index or that particular name, and then it'll walk along the lump names and find the lump with that matching name along the hash index. So yeah, a little bit faster, and did that for textures as well. So makes it a little bit faster to retrieve lumps and stuff, which was apparently being kind of a bottleneck in Doom. Yeah, just the original x86 optimizations seem to have not really bothered with that. But not sure if they were going by profile driven optimization profiler or not back then, but yeah. In any case, yeah, that was a weak point. Yeah, or it's possible on the original x86 version that area of the code just didn't tend to be a bottleneck. I'm actually not sure there. I'm guessing the original x86 PCs were probably more computationally limited and not so much memory limited, whereas here it's more memory limited. And seems I can, to some extent throw arithmetic at problems like it was candy. So yeah. As noted by the ever judicious use of alpha blended console. Could always throw more alpha blending at more stuff because be all like, well, I can't really afford to do most of this rendering stuff, but at least I can afford to make stuff translucent. And the great efficient use of resources that. And again, I remember, yeah, I remember actually I'd tried doing that in a Quake mod before, but it's actually a problem with the way Quake's normal BSP invisibility is done. Is it the original Quake one BSP and Viz utils and similar did kind of make this casual assumption that water was not translucent. So if there's a water layer there, it will block visibility through there and just sort of assume that everything on the other side isn't visible. And if you disable the visibility checking, well then your frame rate kind of suffers a fair bit. Quake 2 was different. Quake 2 did allow water to be translucent without blocking visibility, but would mean if a person wanted to have translucent water in Quake, they'd probably have to go and rebuild all the BSPs, which would actually be pretty annoying. Even though, yeah, they did release the Quake map source, so it's at least possible. Actually, you could almost go and, do a completely free resource redo of Quake, and have it be reasonably authentic to the original. You just need placeholder models and redone textures. So it'd be sort of like Free Doom, but maybe keep a little bit closer to the original. Whereas Free Doom is like, well, they did a replaced all the Doom assets with the free replacement assets, but it kinda sucked pretty hard. like along the lines of, I guess this is usable if you have no other option. Actually, it gets better, arguably, with freedom because um, not only did they make everything not anywhere near as good as the actual original Doom resources, but they seem to be assuming like more advanced Doom ports as well. So they use some advanced Doom engine features, like which is kind of annoying because then you try to use it with a much closer to the original version of the Doom engine, and some crap actually breaks unless you go and modify the engine to be able to support it, which is kind of defeating the point to some extent, but yeah. In an ideal world, you had something like Freedom, it should work with pretty much something pretty much equivalent to the stock Doom engine, and at frame rates and other stuff comparable to the original Doom levels. But yeah. Other hand. Oh. Yeah, it came up. Other hand, I have emulator. This here is more or less what Quake would look like if it were running at 200 megahertz, so yeah. As noted, the slightly off-looking lighting map is noticeable. Yeah. Yeah, the math for the models was compromised a little bit, so it doesn't quite match the environments. But yeah. Yeah, this is, as noted, yeah, a little bit better frame rates, and this is what happens at 200 megahertz. So yeah. This is closer to the ideal of what I can pull off if the FPGA wasn't slow. And the number of rendering glitches can be noted to be a bit less, but there is still the noticeable glitchy effect due to the due to compromising the corrected perspec texturing. But yeah. Pretty much, rather than doing like Quake did originally and doing the perspective correct calculations every 8 pixels, it's doing them by default every 16 pixels, and similarly any span less than 32 pixels is directly using non-perspective correct texturing. So as noted, that's a bit different of a technique compared to what I'd used in any of my own renderers. My own renderers tended to, well, subdivide the triangles instead and stuff rather than doing it, in rasterization, so yeah. Now, in any case, so yeah, I was pulling off an average there of about 15.7 frames per second at 200 megahertz, and in this case pulling off roughly about 80 MIPS. So some of this is due to memory throughput. In this, so 1024 or roughly 1024 hertz, which means it was keeping up with real time during its emulation, which is kind of not too much of a surprise given well, didn't see it obviously slowing down, so yeah. So roughly about 60% or almost 60% of the total time is spent doing memory operations in total, and then 31% is the memory operations themselves, and another almost 25% is due mostly to cache misses. And as noted, yeah, 14% is due to misses in the L1 cache, and another, or 15%, and another 10% roughly is due to misses in the L2. When it misses both of these, that means it has to go to external RAM, which it does account for in this estimate here. However, because it sort of assumes cycles, it's not quite accurate compared to the actual hardware, because the actual hardware runs the external part of the, or the FPGA hardware runs the external part of the memory hierarchy at one clock speed, and the CPU core at another, and so if it's running at a value other than 50 megahertz, the actual cycle estimates are a bit off. It'll tend to underestimate how much the actual hardware would take up in this case, or external memory system hardware would take up. So and as noted, it draw span 16, that's the inner part of the rendering loop, and it's, well, moving word values, which is not too much of a surprise because it's dealing with 16-bit pixels. So Z spans is well, for Z buffering, and this is the scan copy loop. It's a new loop for copying basically the contents of the screen memory out to the external hardware frame buffer. So FDIV-SF basically means floating point divide for single precision floats, and as noted, this magic is done in software. So good old Newton-Raphson loop. So yeah. So yeah, that's that. Draw span 16, so more of the span drawing effort magic as noted. This looks like it's dealing with some floating point calculations. FLDCF, basically that's for converting single precision floats to double during the load operation. So it doesn't actually have a direct floating point load instruction, so it loads a double word value and converts it into a floating point representation, or stores it, converts it back. Um, this is theoretically not ideal, but it is cheaper than having to have, or it's cheaper to use a conversion instruction than to have actual logic in place for doing the conversion when it loads the value. So I determined in the past that the actual performance difference between, having an actual dedicated instruction for single precision loads versus, just doing a D-word load in a conversion operator was small enough to not bother to make it not really worth the bother too much. So, or the bother or the cost. So that's how that went. More of the draw spans function and draw spans function for alias models. And it takes a little bit of time. Whole points, contents. Yeah, it's part of the BSP stuff, I think. FRCP, that's for single precision floating point reciprocal, so more floating point divide logic. More Z spans, more whole point contents, more other stuff. So yeah, seems to be where a lot of the time is going for rendering. Just going to run something here. See if this still feels like working. And no, it does not. And again, I think that's, something I probably disabled to make it work earlier, and then it got re-enabled at some point. why the hell not? Or why not? Will it work now? Maybe. Hopefully. Still no. Yeah. Some of that stuff is actually looking at stuff that should be working because the actual Doom mod is loaded in that, so I'm expecting maybe that's a bug. So it's a fallback case of, you know, just using the normal WAD lookup. See if that makes a difference. Oh, okay. Maybe. No, that should have worked. As noted, I hadn't tried, you know, my credible hacky hex and part recently, so possibly not too surprising that crap is broken, but Yeah, as noted, Diaz pistol is, one of the normal Doom sound effects, and as also noted, you know, we do have a Doom WAD in here. We do have a proper Doom WAD in here, so it should be working. Of course, it sort of, has both a Doom WAD and a Hexen WAD in there because it is, sort of a pretty ugly hack and not actually properly implementing all the Hexen game logic, so just sort of crappily hacked it together from, from normal Doom stuff. Oh yes, and this bug. This is another annoying bug, and I've been searching for this one for a while and not found a fix. So something messes up somewhere in the little process of decoding, but where remains elusive. Touch anything, and typically it will go away. For example, can't comment that out and rebuild it. There's a certain probability that it'll just magically work. Or at least as much as it was earlier. So changing anything here will typically cause the bug to go away, and changing anything in the actual boot sector or boot ROM logic will typically cause it to magically go away as well. And even things like, changing changing the which clock frequency it's emulating at, that can also cause it to magically appear or disappear as well. So it's a bug of a specifically annoying and elusive variety. And since it's so elusive, it's kind of not being easy to actually find what causes it, or to accurately recreate it. So hack is, change it to uppercase and see if that changes anything. And it did not. I'm pretty sure these are old. This one was from Heretic, so will this work? least my really hacky heretic is working. To what extent it could be called working, but yeah. As can be noted, yeah, the hacky heretic yeah, it does show the advantage of, like, you know, using YUV, or yeah. It's all like, yeah, the engine has no reason to care that these two different sets of games resources are, you know, nominally using different color palettes, because, you know, it's not actually using index color. So yeah, an actual 256 color version of Doom wouldn't be able to do this particular effect, because it would, you know, notice that, oh hey, half this stuff is using a different color palette than half this other stuff. But yeah, this version, it doesn't, or, you know, has the logic so that when it's decoding the resources, it will, you know, pick the color, or pick the color palette that goes with that particular lump index, so it can figure out, you know, to use the heretic palette with all the heretic, or all the stuff from the heretic wad, and all the, or in the Doom palette from all the stuff from the Doom wad. So yeah, the hex import works roughly the same way, at least if it were working. This is, yeah. Granted, Heretic doesn't take place on Phobos, but you know, it's a case of good solid whatever. So imagine a world where Heretic takes place on Phobos and is filled with Doom monsters. And, yeah, that's basically what's going on here. technically I could set this particular occurrence up on the FPGA as well, or FPGA as well if I wanted. It's just a matter of copying over the particular combination of WAD files. I've not done it partly because would need to add a good mechanism to basically select which combination of things I want to load, like whether I want it to pretend that it's, you know, whether I want it to try to pretend that it's Doom or hacked Heretic or hacked Hexen or what, you know. I guess if I really wanted, I could, like, you know, try to make the respective games use the correct resources, and thus not need the Doom mods anymore. But yeah, partly it's a case of yeah, partly it's a factor mostly because these games actually tended to hard code a lot of stuff into the engine, like all the monster behaviors and textures and all that stuff. So yeah, as opposed to something like, you know, Quake or similar, where most of the logic was actually contained in the actual game data. So for example, well, at least in premise, you could hack the Quake engine into being something like a Half-Life engine, or maybe use it to run Heretic 2 or something. as can be noted, actually originally when I was hacking this stuff together, you know, Heretic changed a lot of stuff around from the original Doom, but a lot of stuff was still basically the same, like it was still the same basic map format and other things. But a lot of things like sector numbers and line def numbers and entity numbers and all that stuff got changed. So had to remap some stuff and fill in some holes for like various line def and sector types that didn't quite match up with those in Doom. But other than that, yeah, it basically worked. Like, I think originally there was this bug that you'd, well, use this map exit portal here, and like, you know, rather than exit the portal, it would cause all the ceilings to crush down or turn into crushers, like, you know, for the whole map, which was kind of weird and surreal, but and it was kind of weird and surreal to have, like, you know, all the ceilings and the whole whole map turn into crushers, but you know, more or less. But yeah, more or less changed that to make it work, but yeah. And Hexen went over to a pretty much entirely different system, like their ACS system. Which was actually in some ways kind of nifty, because that's more or less similar to what Quake was doing with its Quake C system, but just in a slightly crappier version. Actually, Quake C and ACS were limited enough to where it's almost amazing that they worked at all, but you know, they kind of did, and they served their purpose. So yeah. But alas, since ACS was only really used for map scripting, it still didn't really solve the problem of, you know, having all the other stuff have its correct logic, and so all the entities and stuff like that, all the monster types and weapons and all that stuff was still basically hard-coded into the engine, so yeah. No free lunch there. Forgot about this map. This map is has this annoying mechanic. Basically, the only way you can exit is basically to get through that thing before it goes back up. If you wait too long and the thing rises back up, then basically there's no way to exit the map. And yeah. Right back here. Oh yeah, I forgot. That's another annoying is like, you know, where the secret levels go is also kind of hard coded. So you can get to the secret, but it will take you back to a previous map. So for this map, you'd want to try to find the, you know, not secret exit. Which is actually technically in here, but you know, you'd like, you know, have to find the thing to trigger to basically cause that to lower, and then you can get out of here. Yeah, I spent a while trying to debug that and figure out the logic for making the exit work, which is good solid something or another. I forgot where it's at, but yeah, I do remember. Yeah, I had to work on the logic a bit to figure out what the various line def types were and all that other stuff. So yeah. Yeah, I think if I remember correctly, there's a button somewhere in the map I trigger to make that work. exit get. Didn't really remember how that worked in that map, so yeah. Yeah, and I don't really remember what goes on in this map exactly, since it's been a while since I messed with any of this. Still remember a lot of this stuff better than the Hexen maps, which is something. Hexen maps are more a case of, you know, wander around and try to figure out what's going on, and then not helped by, like, you know, stuff being broken and crash prone in my hack job of an implementation of Hexen. But yeah. And enough of this for now. I'm gonna call it. I've been going for over 2 hours and stuff, but yeah, 25 frames per second for that. Yeah, 100 megahertz. Yeah, 100 megahertz simulation, and spending about 63% of the time in memory ops. As noted, memory ops take up the lion's share of the total execution time, so yeah, but going to call it. I need to use bathroom, so yeah.